Hi, and welcome to our Codelab. In this lesson, we're going to talk about configuring stun within our application, and we're going to do it in two different ways. The first one is, let's say, the obvious way, the one that everyone uses and you'll find in most references and all Codelabs out there for WebRTC. And the second approach is going to be the correct way of doing these things, and we'll explain why when we get there. One important thing, we're not going to talk about turn servers and how to install and configure them in this lesson. We're leaving that to one of the exercises, but understand that that is a mandatory part within your application. Okay? And with that, let's start with the usual or simple way that people add their stun server.
Yes, let's look at the code. So we're in the create peer connection function in the HTML file, and we changed it a tiny bit. We have changed the WebRTC peer connection constructor here, and we're passing a iService argument now. And that iService argument is an array of servers or an array of objects, and each object specifies a server or a list of servers. And what we have here is we specify a URLs, which for historical reasons can be a string or it can be an array of servers. And we're passing stun lgoogle.com port 19302 there.
Okay. Can we see this running as an example?
Of course we can. We just start our session, mute our audio. We have WebRTC internals open. And we're muting again. And if we search for our session in WebRTC internals, we can see the configuration being passed here.
Okay. Okay, so that's like the stun server that we've added into the iServer's configuration of the peer connection when we started the peer connection, when we initiated it.
Yes, and we can see we're no longer only gathering the host candidates, the local IP addresses, but we're also getting candidates with a type server reflexive. We can see that here, type server reflexive, and it contains our public IP address here.
Okay. Okay, now let's go back to the code for a second. And I guess there are several things within the code itself that don't make sense for a real application. And the first one is using the Google Stun server. That's an easy one to spot. The problem with the Google Stun server is that it's not our server. We don't pay for that server, and it might not be there tomorrow. Now, it doesn't seem like much because it's Google and they need to put their infrastructure out there and make it work. But you'd be surprised how many times that specific server has failed or was unavailable because of multitude of reasons. So the first thing is not to rely on a third party or public list of free servers that you find out there. You need to either install and run your own or to go and pay for someone that runs it for you as a commercial service. Now, we've decided to do this in this lesson because we first want to explain the concepts and the configuration and only later deal with the actual installation of such a server or the use of a third party. Okay, so that's the first bad thing. The second bad thing is that there are no turn servers in this list. For almost all applications that you will write, you will need a turn server. It might not be used all the time, but you will need one. So if you're running an application already, go to the list of iServers that you have there and make sure that you have turn servers that actually work. If you don't, that's a problem. And so go fix it. And the third one, which is why we're here, is, well, this is like statically handwritten into the code, which isn't a good idea. Right, people?
Yes. And in particular, if you're adding turn servers, you would end up hard coding the credentials into the JavaScript code. And anyone can get the credentials from there and use them to create their own sessions.
It also limits the flexibility. I've seen many different applications where sometimes they have the list of servers in service turn.service.com, and then they run these, and others would go and prefer to give a specific DNS or an actual IP address of a server based on other policies and logic that they put in advance, because you go and you deploy turn servers across the globe, and you might want to configure a very specific machine for each session. And again, doing that doesn't work with placing the address statically within the file.
Exactly. You want either this geo-distributed stun turn services, or you want, if you have, for example, a medical application, you might need a special turn service that is whitelisted, whose IP is whitelisted in the hospital firewall or something like that. So you need a better way to do this.
Okay. And which approach did we take here at the end of the day?
Let's see. Let me. The approach we took was to add a new message to the signaling server. It's the code. So we add a new message after the hello message in our protocol, which sends an iServer configuration to the client.
Okay, so we had this. We had our client. We have the Node.js server. The client connects to the server over a WebSocket. The moment he connects, he receives a hello message from the server with his allocated ID. Now, in our approach up until now, that was the end of the story. And if I were the caller, I would then simply go and send an offer message.
Yes.
What we're adding now is after the hello message, we're adding yet another message where we give the configuration for the iServers.
Which means we have moved the place where we have hard-coded this from the client to the server, which gives us more flexibility.
We're looking at the server.js file now, and we see that just after we call WSSend for the hello message, we're doing the same for the iServers.
Exactly.
Okay, and if I were lazy, I could have just added that into the hello message as well.
You could have done that, but when we are going to add turn servers, it is going to be an asynchronous call because you might need to fetch turn credentials from your provider, and that will take a few round trip times, like 200 milliseconds maybe.
Okay.
And we also want to have the ability to later update the iServers, for example, because we need new credentials.
Okay.
And let's look at the changes in the client code next. So we add a variable for the iServers that we have. And one of the big changes we made in terms of the protocol is that we're no longer resolving the promise from the connect function once the WebSocket is open, but we wait for the iServers message. The reason for that is that we want to wait before we actually start making outbound calls. So if you paste the full URL, including the hash, to automatically call someone, you want to be sure that you have received iServers. Otherwise, depending on the timing, you might create your peer connection without iServers, and then it will fail.
What we're doing here is making sure that we have no race condition on the side that is dialing. That would be the second browser that we open.
Yes.
So that it will go like this. He receives a hello message, he receives the iServer message, and only then he will send the offer, and not before.
Exactly. That's at the bottom of the file, and we can see we're waiting for the connect promise to resolve, and then And only then we're calling the call function.
Okay.
And we have not changed much in the create peer connection. We're just passing the iService variable that we have received before. So that
Yes.
change is pretty trivial.
And you also changed the message handler.
Yes.
We've added like the iService in there.
Yeah, just a new message which stores the iService in the local variable and resolves the promise.
Okay, so what we've done so far is we've added a stand configuration into our signaling mechanism and into our application. We're doing that by sending it from the server side. We're doing that independently of the connection itself because it needs to be asynchronous when we think, forward into the future. The things that we still need to fix with it for a real application would be to switch from a Google stand server to something that we manage and host or pay for, and to add turn servers to that list. Okay. Thank you. Thank you for being with us in this lesson, and see you in the next one.